Hello everyone, the problem that we're looking at today is in fact not on usaco. It is on the website of Luogu, which is, I would say, the best OJ online judge. So the problem is the copying of books, and the translating is done by Google Translate, so do not trust that. I will just summarize it for you. Right now you have a book, no, you have N books, each with a page number that is less than, okay, 500. And then there are K people you're trying to copy the books with. And now each person copy the book at the same pace, which is 1 page per second. And now you're trying to make the distribution of books to people be optimized so that the total number of seconds taken for all the books to be copied is minimized. However, you can only divide the books such that every single person copies a contiguous region of a certain number of books. So you can have, say, person 1 copy 1, 2, 3, person 2 copy 4, 5, 6, and person 3 copies 7, 8, 9, right? But you cannot have person 1 copy 1 and 4, person 2 copy 2 and 3, because person 1's region is not continuous. Also, you cannot have person 1 copy this, person 3 copy that, person 3 copy this part, and person 2 copy that, because you have to have it so that it's like 1's region and then 2's region and 3's region. So you're basically trying to determine m-1 optimal splitting points to where the m-1 splitting point where you split where the k people, the m people are copying. Okay, so you can pause the video and think about it first. It's a pretty straightforward problem, I would say, and usaco styled. I have to say it, I did this a while back and my code is quite messy, but let's just go through my thinking process over again. So obviously this problem gives off a very, very strong DP vibe, which is why I came to DP. That's my first instinct. And FIJK is obviously the first IP will copying the first J books with ith person, but realize that since n is at most 500, that will give us a space complexity of over 100 MB, which is not acceptable. So then we consider this, Fij equals the first I person copy the first J books, and then realize it is quite simple to transfer from the last state, which will just find the optimal breaking point from the ith person and the I-1th person, which in this case will enumerate it, denoting it by K. And then comes the weird part about this problem. In the problem statement is not only that you're trying to minimize the amount of time taken, it is also that if there are multiple possible distributions of books to people, you're trying to make the latecomers copy as many as you can. So the earlier ones, you try to have them copy as little pages as you can, and the later ones as many as you can. So how do we achieve that? Well, my original method was quite weird, in which I kept track of a Gij array, which denoted which K did Fij transfer from, which would not work because of complicated reasons, and also just because of the fact that it is quite difficult to maintain Gij, even though I was able to do that, and I actually still have the code in here because it would not affect the computing of Fij. It's just more complicated. But noting that if we don't need Gij, we can just delete all of this, and then we'll just have Fij equals max Fij and now, which is the value of now, is just that. But how do we find the optimal distribution without using Gij? Well, a very big brain idea in this problem is that greedy front or back, if it works, then greedy backwards to the front also works. I know none of you guys understand what I just said, so let's just take a look at my code. So since we're trying to have the later people copy as many as we can, basically what I'm doing here is, since we already know the answer, which is just going to be FKM, we already know the answer of the time. We just need to make the later people copy as many books as they can, as long as they don't go over the answer, right? But how do we know that it'll always work? Like, what if the later people don't copy enough? Well, that's not going to happen, because think about it, the later people, we are already trying to have them copy as many as we can. So if that doesn't even work, so meaning that we don't have the latest person copy as many as they can, well, then it must be worse. So if answer told on some distribution works, then it must work under this type of distribution, in which we greedily select as many books as we can for the later ones. So it's a greedy strategy from M to 1. Also, I mixed up the variable names. There's K people and M books instead of N people and K books. So K people, M books. Wait, no, my bad. M people, K books, M people, K books. That is why we're greeting from the Mth one, not the Kth one, because we're trying to have the Mth person copy as many as we can. And there's K books. Oh, okay. And now the answer is just simple because during the greedy process, we already kept track of the amount of time each person is taking. So now when we come back to the problem, let's retrace our thinking process. It's basically, first of all, we notice it gives off a very strong DP vibe in which we have a very foolish state, which is three-dimensional. Noticing it exceeds the space complexity, but not the time complexity. We basically kind of compress it, even though it's not a ruling array, but we still compress this kind of into a more condensed type of dynamic programming array. After we have that, we notice the problem is we have to output the distribution of the book. We have to output how we achieve the optimal answer, not just the optimal answer itself. So we developed the idea of using another DP array, which is basically like establishing a DP tree, if you guys know what that is, but not exactly what we're doing here. Kind of similar. But then we realized that this wouldn't even work either because, first of all, it's just really difficult to keep track of this, but also it's really complicated to actually get it right. So then we just noticed a much, much, much simpler way, which is just greedy. We just greedy backwards to the front and having the back copy as many as they can, as long as they don't exceed the limit found by us. And noticing that actually with this, the DP isn't even that necessary anymore because we can just do a binary search and achieve the same result. But the problem just gave off a strong DP vibe, and I would not be able to sleep that night if I didn't try a DP. That's just me. Okay. So hopefully after this video, you know how to solve the Luogu P1281 copying of books. And thank you for watching. I'll see you next time. Okay, that was the problem review, and now comes the not grammar report anymore, just like the study report for myself if I watch this video later in life. So let me just be honest, I've been slacking off. I've been slacking off so much since January. Like even during the February grind, I was not really grinding. Like I grinded for the last 5 days because there was like a few snow days in a row before February contest and walked a few gold, a few silver, and it just passed. And it's like, yay. But I didn't really grind as hard as January. And I realized this is not going to work out because, well, the next user goes in 8 months, merely 8 months. That is not nearly enough for me to get from 480 in gold to platinum. Which, yeah, by the way, I think I got 480 in gold probably because I this US Open contest, but you know the scores haven't came out yet. But the thing is, that's a huge jump I'm trying to make here. 480, possibly 700, even higher. If I'm slacking off in this 8 month, I am not going to be able to do that. So my plan is I'm still going to make a video every single day, except it's just not going to be as intense grind as January, but I still can't slack off as hard as I'm doing right now. Because let me just show you my grind list, which is right here, the usaco problems. Look at all these difficulty markings. Look at all of these explanations I added before. Like look at those stuff. And then we get to after January. Look, that's a sad day, January. And then all those problems are done between December and January. All of these, look at all that, like 200 of them. And then between January and February, this is all I have. This is all I have between January and February. And then between February and March, just those. That's like less than 50, like 20 something problems between February and March. I mean US Open, but yeah, that's just stupidly small amount for a usaco grind. So right now I'm trying to pick up the pace, see if I can maybe get the feeling back of January, because January grind was not even just a grind. It was actually really fun. So I'm trying to see if I can continue that for the next 8 months, and then I might get even beyond platinum. So as you guys can see right now, if you do reach Chinese, you probably don't, but this says KMP, and then we have more hash. This the Cartesian tree. This is the Gaussian elimination. So I've been doing some template problems recently. And here's the biconnected component, the edge biconnected component, and vertex biconnected component. Those are two algorithms I learned. Convex hole optimization. I already made a video on that. And then we have meet in the middle, double pointer. yeah, Gaussian elimination and Cartesian tree. Those are the few algorithms I'm learning right now. And I also learned the Chinese remainder theorem along with the other one that I do not remember the name of. But I did not write the code or do any problem for those other few algorithms that I also learned, so it's just those. And it's been what, 2 weeks since March, since US Open. This is what I did. So I really need to lock in and see if we can get the grind going again for next December. And if I can get platinum and I don't trust myself to get summer training camp, maybe I can even shift gears to, math or physics or something. All right. So that's basically I'm just making another what did I say? What do I call this? Commitment, obligation here that I'm going to be posting a video every single day again, just like I did in January, which surprisingly, I just noticed that I actually followed my obligation in January pretty well. I actually did post a video every single day, but obviously not after February. So yeah, that's what I'm gonna do now. I yapped for very, very long today. Thank you for watching. See you tomorrow.